Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Hi guys, today we will be concentrating on chapter 7, which is descriptive statistics, where you will be learning on how to interpret tables, charts and various more statistics that will be applicable for your syllabus. What you need to learn from this chapter is that you need to know how the statistics are created and how we could read those statistics to make business decisions. Having said that, let's start with tables. So tables, you know, very easy. It's a matrix of data in rows and columns with the rows and the columns having titles. So it can only show two variables. To tabulate data, you need to recognize what the two dimensions or variables should represent and prepare the rows and columns accordingly with suitable titles. Okay, so well, if you see this particular table, this table has two variables, that is male and females. But however, they are classified into several columns, which has production, administration and sales. So male and female classified into several departments, that's fine, but they said that there are only going to be two variables, and those two variables are definitely male and female. So how you read this graph is 58.4% of males work in the production department, 33% works in the administration, and so on. Likewise, you got to interpret. And one thing is, when you get your totals, when it comes to percentages, make sure your total equals to 100%. Okay. So basic guidelines are here, but you won't be required to draw a table as such, but you will definitely be required to interpret them correctly. They might ask what are the two variables, or they might ask a particular information on from this table which you should be able to interpret. Okay. Next, let's see charts. Okay. So charts often convey the meaning of data more clearly than would a table. Instead of presenting data in a table, it might be preferable to give a visual display in the form of a chart. So charts are not always more appropriate than tables, and the most suitable way of presenting data will depend on the following: what the data is intended to show and who is going to use the data. So in charts, we have several types of charts, starting with bar charts. Bar charts has simple, component and multiple charts. Let's see what a simple bar chart is. It's just a chart with one or more bars in which the length of the bar, right? The length of the bar indicates the magnitude. So you should always read the chart based on the length of it. Looking at example 3.4, a company's total sales for the years from 2001 to 2006 are as follows, right? And see how they've drawn the graph chart. 2001, they have just selected 800 as their spot and marked their upper limit, and then they drew a box like this. 2002, same thing. It is 1200 sales. Just they drew a box here as well. 3 same. 3 is 1100, so same. And 2006, it has 1700. But in the exam, they will give you only this chart. And they will probably ask you, okay, in which year the company had the highest sales? So you should pick 2006 straight away, because in a simple bar chart, okay, data is simply presented. There is no analysis, any multiplication to be done, any addition to be done. No, nothing like that. Simply the height of the bar or the length of the bar is what decides the information. Okay. So, yeah. Let's then look at component bar charts. A component bar chart is a bar chart that gives a breakdown of each total into its components. The total length of each bar and each component on a component bar chart indicates magnitude. Okay, so a bigger amount is shown by a longer bar. Alright, so this is how it presents. It is similar to simple bar charts. But in simple bar chart, you just have the total of it. But in the component, they break it into categories to show what each category holds in the bar. Example, company, the same sales of the company split and shown by 3 products for years 7, 8 and 9. So how you draw this is, first of all, now product, you will start from the lowest item. Okay, lowest item is product C. So you put product C here and mark until 500, as it is 500 here. Then product B is 900. What you should do is, you should mark 500 plus 900, because I'll tell you why. But for now, remember, 500 plus 900 only should be the mark for product B, which is 1400 over here. Finally, you have product A, 1000, which should be marked at 2400, which is here, the total of all. Now, if you see, however, the gaps of A, B and C, they are equal to 1000, 900 and 500. Check it. So C obviously is 500, but B we selected at 1100. 1400. So the difference between 1400 over here in this line, look at the cursor, this line, and between 500 this line, the gap is 900, which belongs to B, right? So basically that is what they want to show in a component bar chart. Now in the exam, they will ask you, they'll not give the information, just give you this way and ask what amount of A has the company sold in 2007. Then you should say not 2400. If you say 2400, very wrong. A, because A is only from 2400, the upper limit, and a lower limit of 1400, which means the gap is 1000. 2400 minus 1400 is 1000. So A basically has been sold at 1000 units in 2007. Okay, so that is how you interpret component bar charts. Component bar charts can have percentages to it, and so the same thing in numbers they have given in percentage. But when taking the percentage, now sometimes in the exam they might ask you to calculate the percentage. In that case, you have to, for A, you have to consider divide 1000 by 2400 and multiply by 100. You'll get 42. Same for B. 900 divide by 2400 multiply by 100% and you'll get 37%. Likewise, you should get your total percentage to 100. If you got 100 as your total, that means you have done it right. And when you mark it on the component bar chart, first you select the lowest percentage as we did for amounts, 21%. And then next you select 21 plus 37%, which is 58% over here. Where see the cursor, the upper limit is at 58%. But the gap between 58 and the lower limit of 21 is 37, which is represented by the space allowed for B section. In this way, see, it's very easy to compare. Now, what they'll do is, now see, in percentage, it shows that C had the same proportion. So you should say in the exam that C's sales are not increasing. It's compared to B and A because it's still at 21% of the total sales. But when you see the amounts wise, of course it is increasing. In 2007 it's 5, but it went to 6 in 8 and in 2009 it went to 7. But even though there's a 100 units increase or $100 increase, out of the total sales, it is still the same percentage. So the company is so far not willing to expand the sales of C. And maybe they are mostly focusing on A because A has 42, 43, 50 and so forth. So it has increased gradually. And they have balanced that increase by decreasing a little bit in B. Maybe because of demand changes and so forth. So basically that's what you're supposed to do in your exam. You're supposed to interpret likewise in your exam. Okay, now let's look at multiple compound bar charts. A multiple bar chart or a compound bar chart is a bar chart in which two or more separate bars are used to represent subdivisions of data. Okay, so if you look at this chart, see, they are just as simple bar charts. Simply they are drawn. Each bar is just marked. Its actual number is you can recognize from this sales vertical axis, right? But the difference between a simple bar chart and this multi-component bar chart is that we show several items in this multi-component bar chart. Whereas in a simple bar chart, we just show only one item. That's the only difference. And also we use a different color to represent the different items. And the purpose of this multi-bar chart is to show different items in the same year and to make a comparison. So by the look of it, you could say which is the least and what the gap is. Because in 2009, there's a high gap of sales between product A and product C. Whereas there's a small gap between product A and product C in 2007. Likewise, to make such comparison. Yeah. Here they say multiple bar charts are sometimes drawn with bars horizontal instead of vertical. So the same thing this way. If you see where I'm moving the cursor, this way. You might have seen this in annual reports if you're working in an audit firm. People must have analyzed it horizontally. The bars are drawn horizontally, not vertically. So that also don't get confused if you see such a change, because it will still be a multiple component bar chart. All right. So see this example. They have given you the interest, commission income and other income for 3 years, and then they have asked you to draw a simple bar chart and a multiple bar chart. So in simple bar chart, you should not show these separately. No. You will show the total of each category. So basically you will be showing 3579 plus 857 plus 62 total. You will be showing 4498 in your simple bar chart for year 2000. But in year 2001 you will show 3930. Year 2 you will show 3179. The vertical totals. That means total income for each year. But in the multiple bar chart, would you do the same? No. You will show each of it separately in the same year, so that you could make comparison by the look of it itself. Okay, that's the difference. A very good example to show you how a simple bar chart and a multiple bar chart works. Alright, let's look at frequency distribution. Frequency distribution records the number of times each value occurs. Basically, the frequency. So, a best example is here, where they show the total number of units produced by certain number of employees. So how many employees produced 65 units? They have taken it from this particular list. Yeah. So 65 is produced by, we see only one. Okay. There isn't any other 65, no? So they put 1 here. 66, we have to count how many 66 are here. Well, there's no 66 units produced by any employee, isn't it? So they have put 0. Look at 70 units. Well, there's one here. 1, 2, 3, 4 and 5. So 5 employees have produced 70 units. And so forth, they have built the frequency distribution likewise. And you must make sure that your total tallies to 20 employees over here. Because the question says data represents the output of 20 employees during 1 week. Okay. So this is what you should in order to check your accuracy, you have to add up the total and see whether it's equal to 20, because this column represents the number of employees. Okay, Then we have grouped frequency distributions. In grouped frequency distributions, you group them to equal classes. Meaning, imagine this is your set of data for representing the number of units produced for a particular set of employees. However, um, you represent that with bands or you with ranges where you divide them to equal class widths or class intervals. That means your range must be the same in every range because the range here is 99 units. Here also it is, difference is 99 units. Here also 99, here also 99. Likewise, everything the difference, it has a gap of 99. This is what you should do when it comes to grouped frequencies. You don't put the number of units simply like this. You categorize them into groups and put the number of employees so that you can make a more summarized table, and this is particularly useful when you have a lot of employees and a lot of data. It's very difficult for you to do it this way. It's very actually difficult for the reader. So for the reader to make it more clearer and understandable, you group your frequency accordingly. Having said that, this group, if you notice, it is not continuing, isn't it? As in, it's ending from 799 here and starting from the next number 800 over here. If it is a continuing data, it will end from 799 here and start with 799 here. Since it's not continuing, it has started from the next number. So such non-continuous data is called discrete variables. Okay. And discrete variables can be considered as continuous in a grouped frequency table. So this could be a possible MCQ question where they ask if discrete variables can be considered as continuous, and you should say yes, it could. In a grouped frequency table, it could. Okay, so now let's see how to apply group frequency contributions for continuing variables. So continuous variables you would be writing like this: up to and including. After that, over 154 and up to and including 163, then you say over 163 likewise. The terms that you use for continuous data only change. Other than that, it's basically like this. Because you can't have 700 to 800 here and then say 800 to 899 here, right? Because then you can't. So if there's an employee who produced 800 units, he has to be in this set and this set. If we change the end point to 800 here instead of 799, that's the reason anyway we will be saying up to and including, so that it's including here and it is over here. So it's the same thing, only the words have changed. So looking at the guidelines for preparing grouped frequency distributions, you have to make sure the size of each class are appropriate to the nature or have similar nature, right? They are similar in nature. You can't group apples with oranges. Of maybe you could group it as fruits. Then you can't mix vegetables. Likewise, it has to have the same nature. Next, the upper and lower limits of each class interval should be suitable round numbers. That means the gap between the range must be round numbers. Now this is 99. The gap cannot be in decimals, which may be 45.5, 99.5. Such interval gaps cannot exist in such groups. And with continuous variables, you must mention the word up to and including, less than, and at least. Accordingly, you first have to understand the scenario by yourself and then apply the correct term to it. So obviously here it will be including and up to 154. Now since we are including 154 here, obviously the first term must be over 154 and up to and including 163. Okay. Let's now look at cumulative frequency distribution. Cumulative frequency distributions can be used to show the total number of times a value above or below a certain amount occurs. There are two possible cumulative frequency distributions for the grouped frequency distribution shown below. So the same example. How you create a cumulative frequency distribution is, first of all, the first number of the band, you put it here. The next number of the next band, you include it here. And then for the second part, you include it here, and the next number of the band should be the ending part of the second band in the cumulative frequency distribution. Then the third one comes here, and the fourth one's end will be 1000, and fifth one's end 1100, sixth one's end is 1200, and 1300 it was not available, but they just mentioned it to complete this line. Okay, having said that, first of all, then after that you should what do I say, create this or enter these signs. This sign is same in all situations. This sign represents greater than or equal to. Okay. Whereas this sign represents less than. So you have to put the same signs on either side. After that, what you should do is, now this is greater than, number of units greater than or equal to 700. How many units are greater than or equal to 700? Totally 20 units. 20 employees have achieved more than 700 units, right? Because everybody are more than 700 here. So you should write 20 here. But how many are less than 800? Well, only one, this one. So you write the same one here. Next, greater than or equal to 800 units. How many employees? So it's starting from this category. 1 plus 2, 3, 3 plus 5, 8, 8 plus 7, 15, 15 plus 4, 19. Or basically you could say 20 minus 1. Because 1 is below 800 units. So 19 people have produced more than or equal to 800 units, whereas only 2 people have produced less than 900 units. Because 1 and 2 are under the maximum of 899 and not 900. Having said that, that's how you read your cumulative frequency distribution chart. So let's take 16 greater than or equal to 1000 units. How does it work? So 1000 units are starting here. So basically there will be 5 plus 7, 12, 12 plus 4, 16. Or 20 minus 2 minus 1, which is still 16. So you write 16 here. And how many employees produced less than 1100 units is this set above. 5 plus 2 plus 1 plus 1. 7, 8, 9. Okay. So that's how the numbers came in here. Fine. So with that we finish cumulative frequency distribution. And next we move on to histograms. Now, presentation of a grouped frequency distribution in a graph is called a histogram. So it looks like this. So the same thing they have, put it. But the difference between component bar charts is that they are fixed together. See, there is no gap between the bars. So if they are fixed together as such, it can be called a histogram, right? So no gaps. Yeah. But they are trying to show a histogram with unequal class intervals. That means now this is an equal. Now if you see these are equal class distributions because the gap is equal in every band. They are now trying to draw a histogram for a situation where the gaps are not equal, as this example. So this is up to and including 60. Here is a gap of 60 to 80, which is 20. But the gap between 80 to 90 is only 10. So it is an unequal class interval. Those class intervals, we first of all, to draw a histogram, there are a few steps. First of all, we find the width of each bar must be proportionate to corresponding class intervals. That means, so this we have to identify what is the gap of each section. So the first one has a gap of 20, second has a gap of 10, third has a gap of 30. Right. Then a standard width of bar must be selected. This should be the size of class interval which occurs most frequently. In our example, class intervals 10, 20 and 30 each occur only once. An interval of 20 will be selected therefore as the standard width. So out of the widths that you found, you must select a common width. Now 10, we had 20 width first and then 10 width and then we had 30. But in this example they have chosen 20. There is no proper reason to it, but just that a common representative for 10 and 30 could be reasonably 20 because it's a middle value. Okay. Then open-ended classes must be closed off. That means the class more than 120 rupees will become less than 120 and up to 150 rupees, a gap of 30 again. I think in my opinion this should be 140 because we have chosen the interval of 20. So this is 42. So the beginning up to and including 60. This one will change to less greater than 40 and less than or equal to 60 with a gap of 20. And here the last sentence more than 120 rupees will change to greater than 120 and less than or equal to 150. 150 which is but it shouldn't be 150, it must be 140. Then only the gap will be 20 rupees. So I think this is a mistake. Okay. Then each frequency is multiplied by standard class width divided by actual class width to obtain the height of the bar in the histogram, which is represented by the term adjustment factor. So the standard class width is 20 and the current class width is multiple, as you see here. So 40 to 60 interval, the size is 20, true. They have gotten the frequency as 4. So 20 is the standard class width and the current class width is also 20. So we have the height of the bar as 4. Here the standard width is 20, but at last they have still considered 150 as that. So what happened here was they are saying the width of such in open-ended classes, width of such classes be the same as that of the adjoining class. That means of the previous class or the forthcoming class, the width can be considered the same. That's why they have considered 120 to 150 as 30 because 90 to 120 is 30. And 40 to 60 as 20 because 60 to 80 is 20. 20 must be your standard class width. However, you may choose to, it can be 140 or it can be 150 because your previous class width is 30. And then you get the height of your bar at these figures, the adjustment factor. Now what you do is draw the graph. So when drawing the graph, your vertical axis must be the frequency density. It is not the frequency. It is the height of the bar, the adjustment factor, which is called frequency density. And the horizontal axis can be the earnings line. Now what you do is draw your histogram for each class continuously. But the upper limits are based on the column height of the bar. Fine. So this is how you basically draw your histogram. So here they say in a histogram in which one class interval is 1.5 times as wide as the remaining classes. Okay, the height to be plotted in relation to the frequency for that class is. So they are asking the height of the bar, which is this column. So we know, so we have to see what is the adjustment factor. They have one class interval which is 1.5 times greater than the rest of the classes. So Okay, so they haven't basically given the frequency, right? The frequency to multiply the adjustment factor 2 to get the height of the bar, because here they have multiplied the frequency with the adjustment factor and only got the answer for height of the bar. So here basically we must assume that the standard width is 1, because they haven't given us the standard width. In that case, the standard width is considered 1 and the current width is considered 1.5. And that's how they got adjustment factor 0.67, which will be the answer D. The reason it is 1 is because they are saying it is 1.5 times as wide as the remaining classes. So it's 1.5 times greater than another. Since they haven't given, so basically it is 1, right? Obviously, because they haven't mentioned anything, and it's 1.5 times the value, which can be, of course, related to 1. And that's the reason they took 1 there here. Okay. So you can try these examples on your own. Remember, frequency must be multiplied by adjustment factor to get your height of the bar. And then this column only will be used to draw your histogram. Ogives. Well, ogives can be used to represent cumulative frequencies, whereas histograms were used to represent grouped frequencies. So ogives, look at this cumulative frequency. 0 to 1, 1 to 2, 2 to 3, 3 to 4. And they have this particular frequency and they have added the frequencies. 5 here, 10 here, 13, 14. How they have added? 5 plus 5, 10. 5 plus 5 plus 3, 13. 5 plus 5 plus 3 plus 1, 14. Okay, that's how they got it. Alright, and then they drew the cumulative frequency column straight away. And the thing in ogives is that they draw straight lines between points. See, as you see here, look at the cursor. It is a straight line. They haven't gone as a curve. You see, it's a straight line in between each of the points. Right? Because it's easier. That's the only purpose. And drawing that in straight lines will give it a term called cumulative frequency polygon or cumulative frequency diagram. And so the straight line graph is known as cumulative frequency polygon. Whereas if it is drawn as a curve, it can be drawn as a curve, no problem. Then it will be called cumulative frequency curve. So make sure you remember the terms correctly. And the thing here, okay, now you might be thinking where to plot the figures. So now when plotting, you should use the upper limit to start plotting, not the lower limit. So see, if you take this number 3, okay, number 3 is cumulative frequency is 13. Okay, so number 13 is the frequency, but the upper limit for number 13 is 3. Therefore, they selected 3 from this horizontal axis. See here, this 3. And only straight to that they selected point 13. They did not go to select 2 here, because 2 is the upper limit for cumulative frequency 10. So they marked 10 for 2 in the graph. So likewise, make sure to plot your figures appropriately. Make sure that you use the upper limits to plot the points on the graph and not the low limit. So let's look at downward sloping ogives. You create this, mark these frequencies by in a downward way, starting with 80. Okay, so see at 0 they marked 80 here, and then the first set is 10 number of times output achieved. So 80 minus 10 is 70, which they marked 70 for the upper limit, the upper limit of 100. Always use the upper limit. And then 20, 80 minus 10 minus 20 is 50. 50 is marked against 200, the upper limit of this band. And then 80 minus 10 minus 20 minus 25 is 25. So which they marked here for the upper limit 300. Same as the previous one where we looked at marking against the upper limit, but what happens here is they basically reduce the number of times or the frequency of each interval from the total frequency, because to get it downwards. So the reason they drew this is to basically, in this case, to show the number of weeks in which output exceeds a certain value. Like to show the how many weeks it basically takes, like the gap, to exactly show within 80-week period. Well, you must be wondering, well, I could draw it, straight upwards. But as you see here, it's starting with 10 and reducing at 10. So if you are trying to draw it upwards, it will become like a curve, something like a curve. If you drew upwards, you will start with 10, go then plot up to 20, then what else? So not 20, the cumulative will be 30, and then the cumulative 50, then 65, then 75. Likewise, you will be plotting it upwards and it won't be a meaningful representation of how many weeks we took for a particular category. So this is going to show within 80 weeks how my output spreads, right? To show that cover, to be a covered way, or to show a very closed perspective to the data, they used ogives. So it goes by minusing each class's frequencies from the total of the frequency. Fine. Alright. Next, let's look at averages.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.